Okay, so now in this problem we are applying the second derivative test to find all relative extrema of this particular function, 2x to the third power plus 3x to the second minus 12x. Now I'm assuming you know how to take a derivative at this point, so that's what I did in this first step. I took the derivative of this original function and was left with 6x squared plus 6x minus 12. And I factored that to make it a little bit easier to find my critical points, which are found from the first derivative. So this right here, factored out, equals x plus 2 times x minus 1, leaving me with the critical points x is equal to negative 2 and x is equal to negative 1. So once I've found my critical points, I will do the second derivative, and you do that by doing the same process, taking the derivative of this equation right here. So when you do that, you're left with 12x plus 6, and that's what I wrote right here. And so once you've taken the second derivative, using the values right here that you found, the critical points, put these points into the second derivative and take a look at what the sign is. In this case, a negative 2 into this function right here will leave this with a negative. And so when you get a negative from a second derivative, what that tells you is that it's concaving down. And if it's concaving down, as I illustrated in this picture right here, you'll be left with a relative max at that point. In this case, negative 2. Do the same thing for your second critical point, x is equal to 1, and you'll be left with 12 times 1 plus 6, and this is a positive sign, and that's all that really matters. This 18 and 18 here don't really matter all that much. What matters here are the signs. So meaning that if you take the second derivative here and you're left with the positive on the second one, that means that it's concaving up if it's positive. So if it's concaving up, what that means is you have a relative minimum at that value 1. So now that you know what they're going to be, a relative max at negative 2 and a relative minimum at 1, take these two values and put them into the original equation to figure out what your y values are going to be. And that's what I did down here. So f of negative 2 put into this equation right here leaves you with 20. Same thing right here. Pretty simple stuff. Just f of 1 putting into this function right here. You just solve, and you're left with negative 7 when you have the x value 1. So at the value negative 2 right here, we knew that that was the relative maximum. That's what we figured out up there. And at 1 you have a relative minimum. And so using those points, negative 2 and 20 is your relative max. X value, y value is 1, negative 7 for a relative minimum. And there you go.